Right. In this derivation of the conservation equation for cars, we used this following theorem, that if the integral of a function is 0 for all a and b in an interval, then the integrand f function f of x has to be 0 for all x, and that's provided that integrand is continuous. Now the proof is pretty straightforward, and it's done by contradiction. Right. So here is what we're going to contradict. Assume there is an f and is an x such that f of big X is not 0. And in particular, let's work with the case where it's positive. The case where it's negative is exactly the same, but just with a few signs. Alright, so let's draw a little diagram. Here's the x-axis, here's x. This is the value of f of x. And now we know that f is continuous. It's one of the preconditions. So the graph of f, whatever it looks like, it might look like something like this. Whatever. It's continuous. So whatever it does look like, there is a small interval, at least a small interval, around big X, in which f, the function, is positive. So, just consider, for this choice of interval, a to b, consider the integral of f of x dx. It's a finite interval, the function is positive in there, and hence that integral has to be positive, but this is a contradiction of one of the preconditions of the theorem. So that means that the assumption in this derivation must be wrong, namely that there exists a big X for which f of big X is non-zero. Since that has to be wrong, it means for all x, f of x is 0. That's the proof.